Hello and welcome to this managerial accounting video. Today we're going to be taking a look at exercise 9.12, which shows us how to calculate the internal rate of return. Okay, so here is our information. Garrett Boom, Farish Enterprises Vice President of Operations, needs to replace an automatic lathe on the production line. The model he is considering has a sales price of $285,000 and will last for 9 years. It will have no salvage value at the end of its useful life. Garrett estimates the new lathe will reduce raw materials scrap by $40,000 per year. He also believes the lathe will reduce energy costs by $25,000 per year. If he purchases the new lathe, he will be able to sell the old lathe for $53.05. All right, so the first thing they want us to do is to calculate lathe's internal rate of return. So remember, in order to find the internal rate of return, we're going to take in the numerator, we want the cost of the new asset, and then in the denominator, we want the savings so that we can come up with a factor, and then we're going to look that factor up in the present value tables. Okay, so I have set up our calculations over here. The first thing we want to do is find out what is the net price of the new lathe. So we're going to start out with the sales price of the new lathe, which is $285,000, and then we're going to subtract the money that we're going to get if we sell the old lathe. So if we sell the old lathe, it's going to be $53.05 we're going to get for that. So the net cost of the new lathe will be the $285 minus the $53.05, $279,695. Okay. Now let's look at our annual savings. We have a reduction of raw materials scrap of $40,000 a year. So that's one savings, $40,000 every year. And then we're going to reduce energy costs by $25,000 a year. So we'll add those together, and that will give us our total annual savings of $65,000. Okay, so like we said, we're going to put in our numerator the cost, so that's the $279, and in our denominator we're going to put the total savings. Then we're going to divide those two, and that's going to give us the factor that we'll look up in our present value table. So this is equal to that divided by that. That gives us a factor of 4303. All right, so we know that this lathe is going to last 9 years, so our N is equal to 9. Oops. N equals 9. And our goal is to find out what the I is, or the internal rate of return. So let's go to the present value tables, and we're going to present value of an annuity. You're going to go to the N equals 9 row and keep looking across until you find 4.303. If you do that, you're going to find that your I turns out to be 18%. Okay, so that is the answer. That's our internal rate of return. All right, so let's make that red so we know that that's our final answer. The internal rate of return is 18%. Okay, so next, if Farish Enterprises uses a 15% hurdle rate, should Garrett purchase the lathe? All right, so the rule of thumb here is we want our internal rate of return to be equal to or greater than our hurdle rate. So the answer is going to be yes, we are going to purchase the lathe because the rate of return is greater than the hurdle rate. Okay. Remember, with internal rate of return, you compare your answer to the hurdle rate. Okay, finally, they want to know, without doing any calculations, what do you know about the lathe's present value? All right, so what do we know about the lathe's present value? We know that the lathe's present value is positive, and the reason is that its rate of return is greater than the hurdle rate. So remember that anytime there's a positive net present value, that means that the project has a rate of return greater than the hurdle rate. So we're going to say we know the net present value is positive since the rate of return is higher than the hurdle rate. Okay, so that's internal rate of return. I hope you find it helpful in your studies.